Okay, I hope you guys can see my screen and can hear me all right.
Yes, yes.
Okay, so yeah, welcome everyone. Thanks for coming to my talk, and I hope you're staying healthy, and I hope everyone is well today. So I'm going to talk a little bit about term-aware machine translation today. So basically, how do we get the machine translation system to understand and to use, rather, terminology from a glossary? So I'll just quickly go over our business and kind of the business process automation side of it so that you can understand kind of the context that all of this fits into. And then I'll talk about the challenges that we faced with searching for terms. So yeah, let's get started right away. So yeah, business process automation. Um, so basically, yeah, so I work for Langu, which is a machine translation company, a translation company, and a large language service provider. And originally, when the business started out, it was kind of more of like a traditional translation service. So they had kind of like a wide network of translators. Each of the translators had some specialty or some domain that they preferred to work in. And as new documents would come in from customers that would like new translations to be done, someone from our company would kind of hook up uh, the document with the translator that would be the best fit to make that translation, depending on the content of the document. And quickly, we decided that this would be a nice spot to kind of inject some automation. And so, yeah, we kind of added this layer of just using this TF-IDF algorithm to take a match between the content of the document to be translated and the previous documents that each translator had translated in the past. And this kind of would help automate the searching and like matching of translators to the current document to be translated. Of course, we still have a human involved in the process that's like overseeing this whole thing. We have, a whole team taking care of the translators, taking care of the customers, making sure that everything goes smoothly and that the algorithm is, making good choices. But this kind of helped to speed up the process early on. And so then, seeing kind of like the nice power of automation, we decided to put machine translation into the mix. And so with machine translation, we now have the source document being translated by the system into the target document. Like I said at the start, the translators had specific domains that they specialized in, and our customers also have specific domains that they specialize in. So for this machine translation system, we actually train a domain adapted model. So we start with a very large generic model, and then we use the data of our customers to fine tune it to the domain that the customer is working in. So this allows us to kind of make more targeted translations that target specifically the customer's language. But then those translations, those machine pre-translations, as we call them, still get passed on to the translators. And the translators now act more like post-editors to kind of like fix up those errors that we know machine translation still makes, and to really ensure that we still have like the highest quality, human level quality translation that is given to the customer. So translators in the translation business are used to working with computer-assisted translation tools. This is a screenshot of our own computer-assisted translation tool. And the way this works is on the left-hand side here, you see the source sentences that are to be translated. And on the right-hand side, the translator has the opportunity to type their translation. In case we use machine translation, this right-hand side is pre-populated by the output from the machine translation. So I'd like to draw your attention to one region here, which is this, the translation memory. So the translation memory is really a database of previously translated sentences that were done in the past, like from different documents for this customer. So it's particular to each customer. The translators are used to having access to this translation memory as kind of like a guide to to be able to keep an eye on the type of language, the tone, and the terminology that the customer expects to be used in their documents. This translation, so sentences that are to be translated are matched against the translation memory database using like some matching algorithms such as Levenshtein distance, for example, and the highest ranked matches are displayed to the translator so that they can decide either to use it wholesale because maybe the sentence appeared exactly like that in the past, or if the sentence is similar, they can like pick and choose and kind of like get a view of the tone and the language used. But the thing is that many different translators still end up touching the same translation memory over time, because basically, like a company like one of our customers has translations done for them like over a long period of time, like over even many years. So since different translators touch this translation memory, it can still become inconsistent and kind of diverge from the tone or the language that the customer might want to use. So for this reason, customers often have a glossary as well. And a glossary is kind of like the customer's last line of defense for how they want their terminology to sound. And this is important because, for example, if the company is working in like the marketing sphere and they're creating, like they want their translations to kind of always have the same tone and the same brand. They don't want to have a different tone because that throws off their brand. Another example, if you have a customer working in a very specialized field with lots of jargon, you really want those terms to be translated consistently in the same way within that field, and you don't want like some other jargon to come in there. So that's kind of where the glossary comes in. And now the challenge for us, like this is how the challenge came to us. How can we use this glossary within the machine translation system to also increase the kind of terminological coherence and consistency of the machine translation output? So we separated this challenge out into two separate sub-challenges. The first one is term search. So basically, we have this glossary, but we have to figure out in the first place if any term in that glossary actually exists in the source sentence anyways. So that's the first challenge. And the second challenge is how, now that we've found the term, we know it should be in the sentence, how do we actually train the MT model to use that correct term? Any questions up until this point? And I trust that if there's any questions that are like being typed out or anything, maybe you can like read them.
Quick question. Did I get it right that from the business perspective, you have a different database to each customer, right? Mm-hmm. Which implies to me, at least, that you usually cannot share translation if it's needed between customers. For example, in my database as a customer, I didn't have the sentence before, but it is in another different database for another customer. So it's not possible that actually I can use as a suggestion the translation from another customer, right?
Exactly. And I mean, that's also important because in terms of like customer data privacy, we don't want kind of data leaking from one customer to another.
True. Makes sense. Okay, thank you.
Mm-hmm. Mm-hmm. And it's a multi-language translation, isn't it?
What do you mean?
Like I saw examples of 3 languages.
Yeah. So the customers often would like translations done in different, on multiple languages. So yeah, exactly. Their glossary can come in multiple languages. Their translation memory can also come in multiple languages. Mm-hmm.
I also have a question, Svetlana. So how does it work between customers and translators? Is it a one-to-one correspondence or not?
No, it's not. So we have different translators that specialize in different domains. Actually they're all over the world as well. And depending on the customer's document that needs to be translated and the domain of that document, we make a match between those translators. So, you know, and of course, it also depends on the translator's availability and, you know, everything. So, yeah, you can have different translators day to day working for the same customer. Like I know that our operations team, in the interest of like quality, does try to maybe sometimes keep the same translator, but I mean, you know, given the hours that people work and all of these considerations, of course, this is not possible. But the benefit in our case, though, is that we actually do have like a really large translator network. So like we really have people available most of the time to make translations, which is really cool.
The source of of my question was also because, so currently my understanding is that many translators can work for one customer, but maybe different customers could have something very, very similar. So it would be very beneficial to gather this. But from what I understood from the previous question, it's not possible, even if it is something standardized like a birth certificate. So birth certificates are all the same, and they come from different customers because probably it's just individuals who ask them to be translated, and still nothing can be done from privacy perspective, right?
You mean in terms of the translation memory? Yes, that is correct. Like we won't share a translation memory between different customers because exactly like you said, the perspective of privacy and keeping data like separated between each customer is pretty important.
Okay. Yeah. Thank you.
Any other questions? Okay, then I'll move on to a little bit more technical topic now. So yeah, how do we make this term search? So we have a glossary, and like, yeah, if you can see in this picture, it's just a whole bunch of terms. These terms are in kind of like a dictionary headword form. So they come without, like the verbs are not inflected, the nouns are not declined, you know, there's not necessarily any specific type of morphology. In practice, also, this glossary can be like terms in the glossary can be like multiple words in length sometimes, or even sometimes they can even have like short phrases. So we need to figure out how to find these terms from this glossary in the source. We need to figure out, are there any terms in the glossary in the source sentence to be translated? So there's a couple kind of big problems that you have to tackle with this. There's smaller problems as well, but I'll just talk about the two big ones. Word formation. So by this, I mean like morphology, like verb inflections, noun declensions, like suffixes and things like this. And then synonymy and paraphrasing. So of course you can have different synonyms, like on the source side, you can have one term, and on the target side, it can be translated in a few different ways. So these are the two things that we need to, the two big things at least, that we need to consider when we're trying to match terms. Like a naive approach might be to use fuzzy matching. So with fuzzy matching, you use something like Levenshtein distance, and you basically just allow a small number of changes between the word in the glossary and the word that you're looking at in the source sentence. There's a few problems with this approach. First of all, you're only allowing like a couple characters change, and so you can only really capture small differences between words. So this won't be very effective for languages, especially that have more overt morphology. Like for example, in Turkish, where you have like all of these suffixes tacked on the end, you're not really just going to be able to necessarily change two suffixes and still consider it the same, or two characters, I mean, and still consider it the same word. Also, this is highly error prone. So you might change one character and get actually a completely different word. Like, for example, in English, hound and mound are like totally different words, and they differ only in one character. And then, of course, fuzzy matching does not handle the problem of synonymy and paraphrasing. So the more linguistically kind of motivated approach would be to lemmatize everything. So we lematize the glossary, we lematize the source sentence, and then we make an exact string match between the lemmas. This is pretty nice for tackling the word formation problem, because lemmatization will reduce those words that are of the same part of speech into like the same word will be reduced into the same form. It still doesn't handle synonymy and paraphrasing though. And then the last approach that you might try would be word embedding similarity. So in this case, you convert the words into a numeric representation in a vector space, and you calculate some distance between the words, like maybe a cosine similarity, for example. So the word formation problem is handled pretty well by this, and synonymy and paraphrasing can also be handled because similar word sentences will be grouped together in the vector space. There are still some problems, like you need to consider the threshold at which you consider a word similar to another word. And also this is prone to the hubness problem, which is basically some words are going to be very similar to a big cluster of words, while others will be kind of like off on their own. But I think that this would be a nice approach to try. However, in our initial prototype, which is what I'm talking about today, we decided to use lemmatization as like a first, attempt and as a first prototype. So that's what I'm going to talk about in a little bit more detail now. So I know this looks like a lot, but bear with me. On the left-hand side, I have an example of an original glossary, like a little mini glossary here in German to English, with some sentences in German and their English translations. So for example, I have aussteigen, which translates to disembark in English, and I have das Handelsabkommen, which translates to two different synonyms in English, trade deal and trade agreement. So the goal with the matching would be to make a match between, for example, like in our glossary, aussteigen, and this inflected form, ausgestiegen, which is the past participle of aussteigen. And likewise, this inflection here. Ideally, we would also be able to make a match between so aussteigen is a separable verb in German. This means that this prefix aus can move to another position in the sentence, and some stuff can come in between. So ideally, we could still make a match between aussteigen despite this stuff coming in between. In addition, ideally, we would have like this paraphrasing of den Ausstieg here. I don't know if you can see my mouse, like I'm waving here with my mouse.
We can see it, yes.
Okay, cool. So yeah, so you have like this paraphrase. This is a noun, but you can see that in the English translation, we're still using disembark. So so ideally, we would make a match between those as well. For das Handelsabkommen, here we have a declined form. So this is the noun in the genitive case, des Handelsabkommens. So we would like to match that. And here we have it as part of a compound. So this is kind of like the expectation from our matching. This is what we hope to achieve. And these are kind of some of the different problems we run into. So on the right-hand side, I have the lemmatized forms of all of this, the glossary and the source and target sentences as well. So you can see, like, for example, the original noun here was das Handelsabkommen, but here I've lemmatized it to der and Handelsabkommen, because this word here is the definite article, and just the lemmatizer, the way it works, it kind of converts it into just this form for the definite article. Yeah, so let's see. After we've lemmatized everything, we are successful in making some of our matches. So the morphology problems we ran into here are alleviated, and here. But we do still see some problems. This kind of separable verb isn't captured very well. Of course, the paraphrasing is not captured. This is a noun, and it's just totally different from the, the verb form. And even in the compound, we don't achieve a match. Yeah. So we can see that the lemmatization strategy is not like perfect for making the matches, but we do get more out of it than from the like fuzzy matching strategy. One more thing that I want to draw your attention to here is that this, like I mentioned at the start, this noun can be translated into 2 different synonyms in English. And without any additional information, like if we're just looking at the source sentence, it's hard to understand which synonym would be the correct one. I mean, personally, like as a native English speaker, I would say that trade deal and trade agreement are almost the same like thing. But if they were slightly different, you might have to make a decision. So this is a problem during inference with machine translation that with this strategy of lemmatization, we also cannot solve. But for training the machine translation model, we have a bit of a cheat. We have access to the target sentence. Yeah, and so here you can see that in this target sentence, we actually have a particular one of the synonyms picked out. So for training the model, we are going to use an oracle that has access to the target to find the correct, like, so to speak, translation of this term. And that target term will be the one that we provide the machine translation model as a guideline for what it should use in its output. Yeah, so that's it for the matching, the term matching. Next, I'll move on to how do we actually get the machine translation model to use the terms after we found them. But are there any questions up until this point?
What lemmatizer did you use?
Yeah, for the lemmatizer, we used the Spacey one. The Spacey lemmatizer has access, has a few different languages covered, but of course, not all the languages, and of course, low resource languages are not really covered there. So yes, that is another problem. We are dependent on the lemmatizer.
I have a question just to make sure. So you had these glossaries already constructed, and the task was to find matches to those glossaries. Okay.
Exactly. Any other questions? Yeah, go ahead.
Did it ever come up as a task to have these glossaries constructed automatically?
Yes, we did have this at one point. So we were provided with some source terms for a biomedical domain, and we didn't have the target translations. So the way that we did this is we actually used a different machine translation system that we had trained in the past to translate those terms. But you know, the results are a bit, you know, not so great because it's not carefully curated by a human. But actually, we did that, and we tested the performance of the whole system, and it was in line with what we would expect. Like the behavior was the same, so it did work. But definitely, I would say it's better to work with human-curated glossaries.
Thank you.
Yeah. Okay. Then I can move on to the topic of term integration. So yeah, how do we get the machine translation model to use the terms? So a naive way might be to ask the model to output the top K hypotheses, and then just double check if any of those hypotheses have the terms in them already, and return that one, like instead of returning actually the top scoring one. The problem with this method is that those hypotheses may not actually have the term in them. Like how, even if you return many of them, if the machine translation model has never seen the term before, that could very well happen. And another problem is that even if you know, increase that K to a very high K, and you have a whole bunch of hypotheses that it provides, and finally you find the one, you know, that has your term way at the bottom, the translation in that case might actually be very poor or unnatural. So this is probably not the best way to approach this problem. There are two kind of approaches that I'll talk about. I want to briefly mention this first one, which is constrained decoding. So there's a bunch of papers here, you can see them. There's more as well on this topic. And in this case, this kind of family of approaches actually augments the decoder in the machine translation system, so that at each time step, the decoder can choose whether to generate a word from its distribution or to insert a constraint instead. Like for example, these guys, Hochkamp and Liu, the way that they did this is they actually created a separate beam bank for every single constraint token. And then each beam bank must output its constraint if that constraint has not already been output in the hypothesis so far. And at each time step, the decoder then picks the highest scoring hypothesis from the beam banks. The translation is finished when all of the constraints have been satisfied and you reach an end of sentence token. So this method is a post-processing method, kind of after the machine translation system has already been trained. And in this case, the decoder is really like forced to include the terms. And so this can result in like overuse of terms or even ungrammatical insertions. One thing that we saw when we were just playing around with this was that sometimes the system really didn't know what to do with the term that we provided it. And basically it would like start translating and it would translate the whole sentence until the end. But since it's forced to use the terms, it would just like throw them there and stick them on at the end. So that's probably not the best thing to do. And also with this approach, word formation, like morphology, has to be handled like after the constraints are satisfied. So if you provide a term that already has some morphology on it, like it has to use exactly that term, and then it has to figure out what to do with the morphology after that. So again, it's kind of, it can be kind of problematic. Like with that said, this approach is really does like show a higher usage of terms, but it just causes some unnatural translations sometimes. So the second approach, which I think is a little more interesting, is actually training the machine translation model with the terminology from the start. So in this paper by Dinu et al., what they do is they basically augment the source sentence with some guidelines for the model to learn when it should use a particular constraint from the start. So yeah, it's mainly a data and training augmentation technique. And the cool thing about this is that the model learns a mechanism that works with any glossary or any term bank at inference time. So it really teaches the model to like perform this action, and whatever term bank you train on, it's not so important. At translation time, you can provide your new term bank to use. Word formation then is also left up to the model, because you're training it from the beginning with the terms. So then it's up to the model how to produce the output. But of course, you know, the model is not forced to use the term, so you might see the term showing up less if it thinks that the probability of that term in that location is really low, and you know, yeah, basically you can have difficulties kind of like overriding its like innate you know behavior of wanting to use the language that it's been trained on. So let me go a little bit more into detail on exactly how this approach works. Here I have a really small example. So again, I have this original glossary on the left-hand side and this lemmatized glossary on the right-hand side. I have this original sentence, Ich gehe zum Laden, which is a German sentence that would translate normally as I'm going to the store in English. The desired output, though, is I'm walking to the store, because in our glossary we have gehen being mapped to walk. So we lemmatize the whole thing, or gehen walking, I mean over here, yeah. But we lemmatize the whole thing. We make a match on the lemmatized source words, and now we know that walk is the target term that we want to provide the model as guidance to use. So what we're going to do is we're going to insert walk immediately after its source counterpart in the source sentence. So we have ich gehe walk zum Laden. And then additionally, we're going to provide the model with the second input signal, which is called the source factors. And in the source factors, we're going to have a 0 wherever we just have like a normal word, a 1 where we have the source glossary term, and a 2 where we have the target glossary term insertion. And the whole point of this is to train the model that when it sees like this 1 and this 2, it gets used to kind of like inserting this, the word like underneath this 2. So again, like this is kind of training this kind of copying mechanism. And then at inference time, you are ready to provide a new glossary with new terms that it's never seen before. And as long as you give it this second input signal of the source factors, it will like make these insertions. Yeah, so any questions up until this point?
Does it also prevent from mixing the two languages up? Probably the source factors, because
Yeah.
otherwise, yeah.
Yeah, so it's actually so basically by kind of, so how can I say this? So the source sentence that it's trained on is this one, ich gehe walk zum Laden. But the target sentence that it sees is like I'm walking to the store. So in the target sentence, it doesn't have any like extra source, you know, artifacts. Yeah, so it's still being trained to output kind of like the correct translation. Does that answer the question?
If we could have multilingual glossaries, would we have 0, 1, 2, 3, and so on? Or there is no work like this?
In our case, so okay, so so far we have trained a German to English model on this. So in that case, we used a German to English glossary, and we kind of like you know, didn't consider the rest of the terms because we're not translating to the rest of the languages. In case you have a multilingual model that's trained to translate from multiple languages into multiple other languages, what you would do is during the training of that model, you would prompt the model with which language it should be translating into, and likewise, you would insert the correct language term into the source.
So all the information about all the translations, you think it would be not so beneficial? Like this entire line that you showed us, that you had the French word, the English word, and the German word. So on the one hand, it's beneficial to have them together. The other, maybe it's somewhat more confusing, creating more information.
Yeah, I wouldn't use, like in this task where I'm trying to train the model to translate from German to English, for example, I wouldn't include the French term because it's not really kind of relevant to the input that the model is seeing at this moment or the output that the model is trying to create at this moment. But like I said, if I'm training a multilingual model, then I'm providing it different sentences from each of the languages. But it's just I'm kind of keeping the language consistency of that sentence like together, like, you know what I mean? So like if I'm training a model on, let's say, German and French to translate into English and Italian, then whenever I show it a pair in French and Italian, then the term insertion is in Italian. When I show it a pair in French and English, then the term insertion is in English. Does that make sense?
I think so. And the number will encode the language, right? So.
Yeah, so the number here is limited to this vocabulary. Just so what I mean is there's just 0, 1, and 2. That's the vocabulary of the source factors. So always you see a 1 when it's the source language, whatever the source language is in that moment, and a 2 when it's the target language, whatever the target language is in that moment.
Okay. So it's really not related to this is English and this is
right.
French.
Exactly. Exactly.
Thank you.
Mm-hmm. Any other questions? Okay, then I'll continue. So yeah, I actually don't want to spend too much time talking about our implementation just because like it gets into a whole bunch of machine translation details, but I'll touch on a couple of things. First of all, for those of you who are in the machine translation field and who are aware of like the machine learning side of it, we are using the transformer model. So yeah, there's a lot of stuff on the screen. This is just the model architecture. For those of you that are not aware of this model, I have added links at the bottom of my presentation. The original paper is by Vaswani et al. 2017, and also there's this really great blog post called the Illustrated Transformer that really like walks you through how the whole thing works. So I can totally recommend that. We differ in our implementation just a tiny bit. So we use the transformer base model. Where we differ is we have a batch size of 496 tokens, a max length of 99 tokens, and the learning rate was this 0.0003. We use the specific implementation of this model coming from Sockeye, and the reason for that is because Sockeye already has this this source factors. It already has this source factors implementation, so it was really easy for us to just grab it and use it right away. Yeah, so that's the architecture that we use. Also, for pre-processing the text, we use byte pair encoding. So for anyone that might not be aware, byte pair encoding is a tokenization method. What you do is you basically so first you take all of the letters, like the characters in your corpus one at a time, and you add them to your vocabulary. And then you iteratively learn where it's best to merge those tokens, those single character tokens, into multi-character tokens. And so yeah, the more merges you make, the more like longer subword pieces you get, and each of those subword pieces you add to your vocabulary until ultimately you reach, you know, the word level, and then you can have like whole words in your vocabulary. The benefit of this is that it handles word formation strategies a little bit better. So you can have like a one root word piece and word pieces for each of your affixes, for example. And so then you kind of have those little pieces that you can put together, you know, into bigger blocks when you're making the translation. This also handles unknown words pretty well because in the worst case, you can just split unknown words into like a character by character, you know, and just have them be one character at a time. And it lowers the vocab size because now you get to choose how big your vocab is. In our implementation, we chose 32,000 tokens for the vocab. So yeah, but what I mean is you can just choose kind of how many times you merge until you reach that vocab. In our implementation, we used a shared source and target BPE model just to make it a little bit easier for like the engineering side to not have to have multiple models flying around all over the place. And it's been shown that this works quite well anyways. And also we use sentence piece as the specific library for our implementation. Again, I've linked here below to the paper by Senrich et al., the original paper for byte pair encoding. And I've also linked to sentence piece, which is the implementation that we used. So yeah, you can explore those if you like. Yeah, okay, I already mentioned earlier about the lematizer that somebody asked me. We use the Spacey and we use their German and English lematizers. And then in terms of the data, actually there's this really great European Union terminology data set in all of these different languages. So it's like a massively multilingual term bank. This is the one that we used for our German to English terms. And for training the generic model itself, we used parallel sentence data that's available from the Opus corpus. we ended up using around 58.5 million German to English parallel sentences. We did have to clean the data a bit, so we removed pairs where the pair is a duplicate, or it's like the wrong language, or it's not alphanumeric, and some heuristics like that to clean up the data. We trained the model for 500K updates, which was around 86% of the way through epoch 2, which is actually the third epoch because we count from 0. Yeah, I think that's it about the implementation details. Before I move on, does anybody have any questions about that?
It was a question regarding the SOC-I. I believe it's a sequence-to-sequence framework.
Yes.
Cool. Thank you.
Yeah, so SOC-I is from Amazon, and they implement the transformer model with source factors. That's why we decided to use it.
During your experiments, have you tried other like bird size, other sizes of bird? Let's say you said that you used the bird. Which one did you use?
We used the base transformer model. Yeah.
Yeah, I'm just curious whether you tried some like a bird small, a bird big, other versions of bird.
Let's see. We did not try bird big because it was too big. Yeah. So this was the one that we went with for this prototype, at least.
Sure. Maybe just it's like it's the easiest thing to play with and understand whether it makes sense to continue into this direction. Okay.
Yeah, exactly. Were there any other questions? I wasn't looking at the chat, so if there's questions there.
I'm following the chat and not yet there.
Okay. All right. So I think that's it, actually. That's the meat of my presentation. But yes, I can show you a prototype. Yes. So
demo time.
yeah, a demo. So this is a prototype that I built using Streamlit, which for anybody out there working with Python, Streamlit is a really nice, easy to use library for making front ends when you're not a front end. Like when you're not a front end engineer. It's a bit limited in the kind of scope of what you can do with it, but I mean, it was nice to make this prototype. So here I have like a little translation input, like pretend this is like, Google Translate. And we can type in some text in German. Like I said, this is a German to English model. So let's say I want to say, I say, ich liebe die Katze. I love the cat. And let's see if it translates. Yeah, so it translates as I love the cat. Now down here, I'm going to add a term to our glossary. I'm going to say, let's translate cat now into dog. So we add this. Okay, and let's see how it translates it now. I love the dog. So you can see that it's using the terminology. In case you are curious, I added this for our presentation, a little debug screen. I hope it works because I just added it. Yeah, so here we can see, here are the subword pieces for the input text. And you can really see ich liebe die Katze, and here is dog. And then here are those factors that I was talking about. So zeros wherever we have just like a normal word, 1 for the Katze subword pieces, and 2 for the dog subword piece. And yeah, this is just some extra metadata that I have. And yeah, you can see it's translating to I love the dog. So does anybody want, I don't know, for any German speakers, does anyone want to give me a sentence to translate? We can play with this now if you like, or I can just take questions.
Who wants to break the system?
Yes, try to break it.
Can you use this also for non-translatable items? So terms that, or any names that won't change in the translation?
Like, can you give me an example? We can give it a shot.
Yeah, let's say you have an acronym that doesn't change in the translation.
For example, BERT.
Or product name, brand names, that kind of
BMW, yeah.
Like this?
Yeah.
Okay. Without the glossary? With the glossary? Just by itself?
Well, it should translate with the same term.
So you would like me to put Bert as a term like
Bert,
this?
right? Yeah.
Okay. Let's see. Let's give it a shot. I mean, I don't know what's going to happen.
Okay.
But shall we try? I'm just curious now with some brand like BMW, like auto brand, but without glossary. Let's see whether it translates BM, like it's in German. Okay.
Oopsie. Yeah. Like this?
W in the last one.
Oh yeah.
Yeah.
Sorry.
I know it's a presentation.
I can turn off the glossary completely.
Yeah. And let's see what is a kind of normal, like normalized baseline. Yeah, just a baseline. Cool. And yeah, but if you, for example, update the glossary now with some other brand, so explicitly replace, we will see whether the terms, acronyms handled nicely. As
how about like this?
Well, don't start a holy war, but yeah,
okay,
sure, we can try that. Yes.
Let's see.
Yeah, works or not capitalized, of course, because it's because it can be a noun. Yeah. Right.
Can show the debug. Cool. Yeah, so because the way the lemmatizer works, it ends up lowercasing Volkswagen. So yeah, it ends up inserting this lowercase Volkswagen, and I think this is why we have the lowercase in here.
Yeah, and it's split. Yeah, nice.
Did you manage to make it work for verbs with a separate prefix?
Yeah. So with the lemmatization, typically, yeah, it doesn't like. It's not always the best, I would say. What's a good example? Well, we can try aussteigen, like in the previous example, maybe. It's just all I can think of off the top of my head. And maybe we can translate it as, instead of disembark, like what can we translate as?
Get out.
Get out. Okay. Yeah. Nice. And then we need a sentence. So maybe alle Passagiere steigen jetzt aus. Maybe. Let's see. Okay, yeah, so that's nice. It works after all. Yeah, I'm never sure, like when I'm running this demo, if it's going to just kind of ignore everything. Okay. So we can see, yeah, it didn't actually insert the term. I mean, it makes sense.
How did you see this?
So if you look at this, can you see it here?
Yeah.
The rod. Yeah, so here I have the subword pieces.
The factors.
Yeah, steigen jetzt aus, and there's no get out inserted. And it's like I said, so the problem is really coming from this term matching. So when we lemmatize, like we've lemmatized aussteigen, but we can't like match that against steigen aus.
Yeah.
Yeah.
And even if it could, I imagine it would be problematic, possibly if we have two candidates in the glossary. So we could have a glossary entry for steigen, and we could have a glossary entry for aussteigen, and then we could easily run into a problem, I imagine.
Yes, exactly. And those are the types of things that lemmatization won't handle for you. So in our future work, we want to try with word embeddings, which are kind of going to hopefully match similar word senses to each other and not be so reliant on the exact like form of the string, actually.
And how do you decide actually what match is the best if two possible matches are possible? Like in my example about aussteigen and steigen.
That's a good question. Trying to remember. So basically, like I have steigen and aussteigen. Yeah, then we choose aussteigen. Yeah, because after speaking to our like actual translators, we did run into this problem where we had kind of like substrings and like longer strings that encompass them in the glossary, and our translators basically told us, please use the longer string first.
Okay.
And that's better than making the mistake the other way. So we select the longer string.
It could also be a partial match, like a partial match there and partial match there. But if the rule is just to be as greedy as possible,
yeah,
it just decides automatically.
Exactly.
Thank you.
Mm-hmm. Any other questions or anything else I can put into this thing and then we can break it?
I think Nina suggested an example in the chat.
Can I see it from here? Yeah, like this maybe?
Nina, would you like to comment?
I'm copying it. And should we add any kind of term to the glossary before this?
No other comments left yet.
Maybe we can translate this word Schachteln somehow else. My German is failing me. Or yeah, so it would be boxes. How about I don't know, packages or something? So notice I've added Schachteln, the plural, and packages in the plural, and the lemmatizer has converted them now to remove this morphology. So I have a singular and a singular here. And let's see how it translates. Okay, it does include it in its input. And yeah, there's the new translation using packages instead of boxes.
Cool. I do have a question regarding the metrics. Well, actually two questions. What metrics did you use when you were training the system? And another question will be regarding the metrics of the translation quality of post-editing, like a company-wise from business perspective.
Yeah, so during training the system and evaluating it, we use BlueScore. Unfortunately, BlueScore is not that great in this case because basically at test time, we use a different glossary to test with, of course, like a completely different test glossary. And those terms are not reflected in the reference that we have. So, of course, BlueScore will kind of penalize the model for doing what we tell it to do, like to insert those terms. So that is one problem. Another problem with this is that we don't have right now a carefully crafted human-curated like test set with the terms checked by the humans. So our kind of like gold standard, let's say, for the terms in themselves is coming actually from the lemmatized term matching system. So we actually miss a lot that way, and we're aware of that. Yeah, that's a problem. For the term usage rate, we basically use like it's very similar to term accuracy. We just take the difference in the number of terms that are used versus the number of terms that should have been used over the total number of terms that should have been used. And that is our metric for one sentence, and then we take the average over all the sentences in the corpus. So those are for metrics. And then your second question was, oh yeah, on a company-wide level. So on a company-wide level, we use Blue Score typically, but in the ideal case, when we have it available, we would like to use human post editing time. So like I said, we have human translators in our translator network, and the whole pipeline of like the company's work passes, from machine translation to the human post editors. And then depending on how long it takes the human post editor to make changes to the machine translation, the less time it takes them, for us, the better that would be, because that means we can, push more translations through and make the translation speed faster, of course. So that is really like the metric that we would like to optimize. Currently, we don't always have it available to us, but when we do, we use that.
That's cool. Thank you.
Mm-hmm.
I've just thought about something we could do with this example about the Schachteln.
Mm-hmm.
So actually, I think it's very interesting that you do use parameters inside. So I think if you add an entry for auf dem Tisch, so in dative.
Mm-hmm. Like this?
Yeah, and then you just for a test, I don't know, you can say on a chair just to make it obvious. Yeah. Probably
like
what will, yeah. Do you also think that what will happen is that it will react still, even though the case is not the one that we have in the sentence?
I think it will, because the lematizer should remove these case artifacts, and we can see here actually that what the lematizer has done, which is a bit weird. So it did remove dem, like it did convert dem into this der, but then it decided to do this for Tisch, which I think is a bit odd. But the good news is that when we do this for the matching, we're going to lematize the source sentence in exactly the same way. So we should probably see this as well. And then let's see. Let's just see what happens. On the chair. Yeah. Oh, nice. So another nice thing is that our previous term here, Schachtel, being translated to package, is still being incorporated. So now we have both of those terms being incorporated. Nice, thank you.
That's cool. All right, guys. More questions for Svetlana for today? Otherwise, probably it's time to think about all the deep knowledge that Svetlana has shared with us, and probably come back sometime in future. If you ask, probably Svetlana will be happy to present other achievements anytime soon.
Yes.
At least I hope for that.
Yes, and if you like, you can always contact me on LinkedIn.
Thank you very much.
Yeah.
So again, thank you everybody for joining, Svetlana. So
thank you.
Thank you so much.
Bye. Bye.
Bye bye.
Thank you.
Bye bye.
Thank you.
Forgot to ask. Recording will be available. I will share this on the meetup. Yeah.
Okay.
For those who joined us today, probably it's not so important because the knowledge has passed. But yeah, anyway, I needed to say that. All right. So again, I really enjoyed the talk. Svetlana, thank you for your time, and everybody, thank you for very wonderful questions. At least some of them still are in my mind. I need to overthink of them as well. And I hope to see you at next meetups. Yeah.
Thank you, Jochen.
Thank you very much. Cheers. Bye-bye.
Bye.